Hi, everyone. My name is Connie. Welcome to the Africa ASR workshop. To get started today. Hi, everyone. My name is Connie. Sorry, there's a feedback on the other window. Anyways, to get started today, I'm going to run you through the workshop. We're going to have some introductions from the 3 organizations that work together to bring this workshop. And then we're going to have an introduction to speech recognition for African languages. And we're going to have a 10-minute break in between there. And then we'll cover the hackathon challenges and resources. First off, our first speaker is Delilah from Zindi. Welcome, Rose.
Thank you so much, Connie. So hi, everyone. Thank you so much for joining us for this amazing session. My name is Delilah, and I am the Data Science Community Coordinator at Zindi. And for those who haven't been introduced before to Zindi, we are here to build AI together. And Zindi is a social enterprise. We can go to the next slide. Zindi is a social enterprise which is working towards building a community of vibrant data scientists across Africa in order to solve the world's most pressing problems. Yes, we can go to the next slide. Yes, next slide. Amazing. So as I've mentioned, Zindi is working towards to build a community of data scientists across Africa to solve world's most pressing problems. And we have one and two of our amazing users who are talented and who are working to solve these kind of problems. And first of all, we have Lawrence here and Maria Matoyebi, who are one of the people who have been working towards the hackathons that are on our platform in order to solve these problems. And they started off from nothing, and they did not know how to even work around a data science problem. And they built courage, did their first submissions, and they were able to solve these amazing problems. And they're now topping the leaderboards. So I hope that you are encouraged and motivated that today might be the first time that you are taking up the challenge to do your first submission, and you're going to make it on top. Yes, next slide. So for the Zindi, as we mentioned, Zindi being part of the team that works together to help you in your careers in data, we at Zindi acknowledge our users and help them build their careers in data science by helping them build up their skills, evaluate their skills, and get high profile and high quality jobs of being data scientists, data engineers, and obviously data scientists in general. And the most important thing about Zindi platform is it helps connect like-minded data scientists and data enthusiasts to come together, solve these problems, and interact with each other and help motivate each other into solving these problems that are happening or are currently in Africa using data. And another thing about Zindi is that we work together with amazing companies that are having massive data to solve problems and definitely source for talent in order to help them grow and solve the problems. And now to emphasize on how you grow your skills in Zindi or using Zindi is that first of all, I know you're a beginner. Maybe you might be a beginner. You might be shocked. How am I going to start solving these problems? Don't worry about it. Zindi got you covered, where we have tutorials where you can help. You can start doing machine learning basics. You can dive into advanced data science skills if you are an advanced person. And you can look at computer vision and NLP, and you can dive into solving these problems. And another thing, you can just start off by looking at the tutorials if you're a beginner and just do your first submission, get to learn from our amazing community, and this will help you grow your skills and definitely put you on the map as you become a data scientist. Another thing that Zindi will help you with as a data scientist is, to the next slide, please. It will help you build your profile. As you work on these data science competitions, it will help you gain the skills, the knowledge, build a portfolio, putting up your projects, that the projects that you put on GitHub and that you have solved this particular problem, helping this organization maybe make sense of their data or just help solve a particular problem that's happening maybe in the health industry. You can build a portfolio that will help you even maybe confirm that you're an enthusiast, you're a data scientist who can put the hard work into it and do the practical ability, and it will help you build a portfolio as a data scientist and help you become a professional. So that is something that Zindi will also help you with. And also, to the next slide. Another thing, it will help you get a job. So an amazing thing about Zindi that was really developed by the amazing hard work of the developers was the Zindi profile. So if you go to our platform, on the Zindi profile, you will find where you can just put in your details. Maybe you're advanced in this particular area in our expertise of data. Maybe is it data engineering? Is it data visualization? And it will help you even when you're taking part in competitions. We'll be able to recommend to you job opportunities. If you're a beginner, we can recommend you job opportunities that will suit your skill set and maybe opportunities that will help you grow in your career. So we are again advancing towards helping data scientists in Africa get job and solve problems. So please ensure you check also the Zindi profile in order to build up your skills, enable us to get your data, and we'll be able to again recommend to you amazing job opportunities that will fit your skill set. And yeah, to the next slide. So currently, as Zindi, we have 26% women represented in our platform, 42 African countries represented, and 277 competitions and hackathons that have been currently hosted in our platform, and amazing community of data scientists who are 35,000 in number. And definitely you'll always find someone to help you in your challenges. In case you're facing any blockers in your competitions, just feel free to use our discussion forum to help you solve these problems or just know how you can work around them. And another thing that I'd like to highlight and mention that's going to happen this year is the largest inter-university hackathon. So that is called the Umoja Hack Africa Hackathon, which will be happening in March 19th to 20th in 2022. And feel free, if your university hasn't heard of this opportunity, or you're based somewhere where you feel like Zindi hasn't been represented, please feel free to reach out to us and check our social media platforms. We'll help you to get started and prepare for this amazing hackathon, which will be a big thing, and it will help you in your career, and it will also put your university on the map. So if you feel like you want to be part of our team of ambassadors, or you feel like you want to be a change maker, putting the data scientist in your country on the map, please feel free to reach out to me at delilah.zindi.africa, delilah@zindi.africa, so that we can get you started in making you a change maker in your country. And definitely follow us on our social media platforms at Zindi so that you can get acquainted to what is happening, the events that we're hosting, and definitely the Umoja Hack Africa, which will be the largest event that we'll be hosting. So feel free to reach out to us, and thank you so much.
Thank you, Delilah. And next up, we have Aanu from Data Scientist Network.
Hi, thank you very much, Connie. Good afternoon, everyone. My name is Aanu Oyeniran. I lead delivery and performance for Data Scientists Network. So I'll just quickly run through what we have. I might be speaking more in details to what we have on this slide. Data Scientists Network, formerly called Data Science Nigeria, we used to be a non-profit organization which is committed to raising 1 million AI talent, artificial intelligence talent, and building AI solutions that will improve the life of well-being of 2 billion people in emerging markets. Just very recently, we transitioned to a social enterprise whereby we had to refocus our strategy into three things, which I will be speaking to shortly. The first is a community for learning and research. We're now focusing majorly on our community. I mean, our community will be speaking to a community of learners, a community of practice, quite a lot of our community of researchers, community of startups, so that we can put all of what we have together. I mean, in terms of using AI to develop solutions to support the life of 2 billion persons in the emerging market. Secondly, is our product. We're now focused into developing products. Like I said, DSN, Data Scientist Network, just recently transitioned to a social enterprise, thereby giving us the opportunity to build commercial products which would be used for social impact. And this we are very focused and strongly committed to doing. And third one is the partnership. Now, we've noticed that for us to deliver on our product, there's need for us to expand on our networks. I mean, in terms of getting much more partners into delivering these solutions, which we are very much open to. And one of the example is partnering with Zindi and Gogo on this very massive platform, which we're going to be doing massively and we're going to be flogging in the next 5 years of our calling. Please to the next slide. Okay, so before doing this, I'll just take a while to quickly talk about our evolution. So our evolution basically, we've evolved from learning and community to research and good and social good applications. Data Scientist Network has also evolved to corporate support and solution development, as well as startups, AI ventures. We've done more on AI vertical partnership and AI for national development. That has been our basic evolution from 2006 to 2011. Now, our major milestones will include our first artificial intelligence, which happened in 2016. We also had a kickoff of global mentorship and capacity building. 2017, we moved quickly into executive. We executed our first consulting job, which was a nationwide one, which was done in Nigeria in particular. We also had our first inter-campus machine learning competition for 95 Nigerian universities and polytechnics. We moved on 2018 to artificial intelligence for kids summer school, which kicked off in 2018. We also have our first of its kind knowledge box, which has seen over 17,000, which has over 17,000 AI videos. 2019, we moved on to pan-Nigerian AI knowledge sharing. We had a free introduction to machine learning classes in over 30 cities, and we won second best academic poster at Deep Learning in Daba. So these are little of the awards which Data Scientist Network has won. We had the number one intelligence AI learning community and solution delivery network in Africa. We won this at the Marshall Impact Award at Deep Learning in Daba in 2019. Data Scientist Network also won the best academic poster at the 21st edition of the Global Economic and Computation Conference. Data Scientist Network also won, is the only African finalist at the 2021 X Prize competition on building advanced AI algorithm to address COVID-19. Now, quickly to moving to the three core strengths, which I said we are going to be moving on. I mean, in order to rework and strengthen our model, which is speaking to our current focus. I mean, in terms of what we're going to be looking at. The first is the community. Like I said, we're going to be working so fully on our community. I mean, our community currently now, our community has activities lined up for all community members. I mean, people that are looking to grow their career in artificial intelligence. If you are a novice, you have not kicked off, you don't know anything about that. We have that detailed. We have community of learners, people that are ready to learn. We have community of professionals that are ready to mentor. We have a detailed calendar, which at the end of this event, I'm going to ask that you check through our page for you to see a detailed community and events that are lined out throughout the whole year to support you to becoming a very professional artificial intelligence talent. I mean, professional when it comes to that. So we have all of these things detailed. Secondly, is our products. Like I said, we have 3 dedicated products which we are working on, which we would be launching very soon on a commercial basis, which makes us to be the social enterprise which I've spoken to. And talking about our partnership model, we have gone ahead to also have product delivery partners who would help in driving and making sure that we achieve our goal in terms of our go to market, our product development. We have expert consultants who are now working directly with us, consultants who have at least a minimum of 20 years plus experience, industry experience. Also, I would get to say that we have service partners network, which we are building. And we also have some in our database, speaking to our training, international admission, and certification. So these we have put together under our DSN new partnership model, which we believe will help us achieve and help us raise 1 million artificial intelligence intelligent talent. We would also go ahead to build AI solutions to support 2 billion persons in emerging markets. These are put together by our internal culture, process, delivery, governance, finance, and admin team, who coordinates this at every point in time to make sure that we achieve on these 3 partnership, community, and the product model which we have put together. Next slide, please. So in terms of our products, these are the categories that we're looking at exploring and getting to really build AI solutions. I mean, talking about career tech, fintech, retail tech, ed tech, platform tech, and health tech. So we're working on building AI solutions in all of these categories, which we believe that would help us to have a global impact and also get to establish our footprints, which we have established, which we are continually getting to build on. Next slide, please. And also, like I said before, this is speaking to our calendar. This speaks to the community calendar. Um, like I'll quickly run through. Data Scientists Network is currently, if by following us, I'm sure you'd see that we're going to be kicking off our project participation very swiftly. I mean, talking to helping to build in industry and hands-on project experience in terms of data visualization. So the project is kicking off just next week. This is targeted to help build our community. I mean, owing to the fact that we're working with our vision of raising 1 million artificial intelligence talent. So we're going to be having a project participation which will be basically focusing on national financial inclusion, and we're looking to help use this to develop our community members. And aside developing our community members, we're also looking to use that to contribute as one of the things I've always done in terms of giving back to the society. So this calendar is readily available on our platform. I'm sure you can always um, get um, get to our platform, read through, and I'm sure that you can easily at any point in time just register for any of these courses, which will help to build and strengthen your knowledge and skills. Next slide, please. Yes, so this is speaking to our partners which I had spoken to. We're looking at service partners in all of these lines: AI and data science education, training providers, data science project consulting and product delivery, AI data science talent management and deployment, AI data science service for small businesses, data warehousing consultancy, data governance and ethics consultancy, data completion, collection and research companies, and edtech service deliveries. These are our current DSN service partners that we're working with. We're still looking to working with quite a lot, and you're free to walk up to us. You're free to reach out to us if you also carry a vision of raising 1 million AI talent. We are very open to receiving partners who we are sure that carry this goal, and we can together get to achieve this goal of raising 1 million AI talent, and we'll go ahead to build AI solutions to support 2 billion lives in emerging market. So next slide, please. So, like I said, also one of the things we have also done is helping to build AI talent, and this is also pushing back to our very goal. I mean, our objective of raising 1 million AI talent. We have a dedicated AI hub at Yaba, Lagos State, Nigeria, whereby we have AI incubation participants. This is our first cohort which we have run. So these are 12 dedicated AI startups which have opportunity to mentorship. They were mentored by the DSN team and network, and they also have access to all of our networks. I mean, in terms of connection, in terms of access, in terms of opportunities, in terms of funding. So this we currently run in Data Scientist Network, and you are free to visit www.datasciencenigeria.org/AI startup for more inquiries. Next slide, please. And finally, you can always reach out to Data Scientists Network through this and do. Our website is www.datasciencenigeria.org. Our Twitter handle is Data Science Nigeria, Data Science NIG. So feel free to just connect with us on this, and we are always very available to feed you back and give you the necessary support that you need. Thank you very much, Connie. That will be all from our end.
Thank you, Aanu. And next up, we have a message from Yossi Matias from Google.
Hello, everyone. My name is Yossi Matias, and it's a great pleasure to be with you today. Google is committed to Africa, and just 4 months ago, we have announced our $1 billion investments in Africa digital transformation. I was in Africa a few years ago for the inauguration of our Accra research team in Ghana and the inauguration of the African Master of Machine Intelligence program, which we co-sponsored. And I was highly impressed with the potential we have in Africa. I now have the pleasure of working closely with our Accra team, which is exciting work on foundational machine learning, as well as work that uses machine learning to solve problems at scale. For instance, the Accra team showed that using computer vision techniques applied to satellite imagery, we could identify building boundaries at continental scale. The result of this approach was released in the Open Buildings dataset, a new open access data resource that contains the location and footprints of over 500 million buildings across Africa. The research team in Accra is working on other exciting problems, as well as collaborating with the local AI and machine learning ecosystem. And by the way, the team is growing. Today, more than ever, there's an opportunity for people to learn how to harness new technologies and solve big, important problems. And improving our technology for African languages is a hugely important problem. Progress in ASR, TTS, and translation is transforming how we interact with technology and with each other via technology. Removing barriers of modality and languages can be done better than ever before, making content and services sustainably more accessible. And getting better language understanding in African languages could open the door to many product opportunities, which would be available to many more people. And with the rapid pace of progress in the field, there are many opportunities to innovate and find new ways to accelerate development of language technologies. And in the language space, it's particularly important to empower and help grow local talent, from researchers to developers to linguists and general NLP practitioners. So I'm particularly excited about this hackathon. I hope you will find it a great experience and an opportunity for personal development, as well as for making an impact on society. Wishing you a great event. Thank you.
Thank you, Yossi. And next up, we're going to move into the workshop training piece. We're going to start out with Don Vanesh from Google, who's going to give us an introduction to some of the work that the speech technology team has done, and also share more about the importance of speech recognition in African languages. Then we'll have Sandy Ritchie and Elena Aksanova, linguists from Google, go into the workshop pieces on model training and data collection.
Hi.
Hi, everyone. I'm Don Vanesh with Google's language technology team, and it's a great pleasure to have you here at the Africa ASR workshop. The last few years have seen lots of interest in bringing language technology to many more of the world's languages. And, with more than 2,000 of the world's 7,000 plus languages spoken in Africa, it's clear that there's a lot of work to be done for Africa as well. Language technology, of course, can help folks break down language barriers and access information by voice. So it's really important that we make it available for as many languages as possible. And at Google, we've actually been strong believers in bringing language technology to more languages for decades already. We've worked on Unicode, we've worked on fonts like the Google Nodo fonts, covering many writing systems. We've worked on keyboards. We actually have more than 900 languages supported in Gboard, the Google keyboard for Android. And we've been working on extending speech and translation technology to more languages as well. But it hasn't just been happening at Google, right? Another trend over the last few years has been open source tooling that's been enabling more and more people to build language technology for their own languages as well. And it's great to see such interest from all of you in building language technology for more languages. This workshop will touch on tools like ELPIS, which was built by the Australian Centre of Excellence for the Dynamics of Language with a little help from Google. And ELPIS is a tool which makes it much easier to build speech recognition systems in new languages. But you can also use other open source tools to build other language technologies. So, for example, you can use Colab and Joey NMT, and you can build machine translation systems using those two tools together. and like the Masakane research community has been doing for a while in Africa. And you can also build third-party keyboards on Android using open source platforms like Keyman. So, there's really lots you can do these days in terms of building language technology for your own language using open source technology. Today, the focus will be on speech recognition systems, but I hope you'll also explore some of these other technologies later on as you learn more about language technologies. I hope you'll find today's workshop on building ASR systems. ASR means automatic speech recognition, right? I keep saying that acronym. I hope you find this workshop on ASR systems helpful. And if this is the first time that you're building an ASR model, the first models that you build might not be super high quality just yet. And I actually think that that's all right. You'll very often be building the first model ever for a particular language, and that's a big milestone, something you can be proud of and happy about. You'll be able to continue to improve from there, right? Once you've built the first model, you have the groundwork, and then you can sort of continue to improve from there. It's also worth remembering, right, that the research is continuing to move super fast in this area. So people are developing better algorithms all the time to work better in low data scenarios. So, you'll be setting an important first step when you build your first ASR models. And like I said, it'll lay the foundations for future work. Now, as you work on building out language technology for more languages, I really encourage you to also share your learnings along the way. You can share them with others informally, but you can also consider doing a more formal write-up. There are workshops and conferences, and actually the Language Resources and Evaluation Conference, LREC, that's LREC, is happening in June this year, and you can still submit work to some of the workshops there. So I would definitely encourage you to take a look at their website and see what workshops might be of interest. But for now, I will wish you, a great event today. I'm really optimistic that as more people pitch in, language technology will be able to cover many more languages, and your expertise will be invaluable here. So thanks for joining this workshop today, and I wish you a very inspiring and educational event.
Intro to language technology, overview of speech recognition, and then we'll have a 15-minute break in between, and then we'll go into data collection and model training. Over to you, Sandy.
Hi, everyone. My name is Sandy Ritchie. I'm a linguist at Google. My area of expertise is in building ASR systems, so speech recognition. I'm going to use ASR, which is the acronym for speech recognition, automatic speech recognition, or ASR, a lot in this workshop, so just get that clear. Today I'm going to talk a little bit about speech recognition, the kind of technology behind it. But before we go into the more detailed overview of speech recognition, I just thought I'd give a kind of more context on where speech recognition sits within the kind of larger field of language technology. To start off, I think it's a good way to sort of think about the levels of support which are available for various languages in the world is to think of them in this kind of pyramid structure. So if we start from the bottom, there are more than 7,000 languages in the world, and of those 7,000, around half, so around 3,000 or so, have some kind of writing system. And you might not think of writing systems necessarily as a language technology, but it is the foundational language technology on which every other language technology is then built. And moving more into the kind of digital realm, as Dan said before, at Google we support around 900 languages on the Gboard keyboard and Android app. So more than 900 languages actually have some kind of digital input method on Android phones. And then what's really far behind everything else is every other language technology like ASR, TTS or text to speech, automatic translation, and then smart assistants. They're only available in between 10 and 100 languages depending on the technology. Next slide. So first of all, writing systems. It's funny to think, but writing is a technology. It's the oldest and in many ways like the best language technology. What's really revolutionary about writing versus what happened previously is that you can communicate language data, language information, asynchronously and atemporally. So you don't necessarily have to be in the same, physical space near the person who's producing the language to be able to, then retrieve it later. So what writing really gives us is the ability to store and then later retrieve language data. And it's interesting looking back at the history of writing. I think the very earliest examples that we have are from the Sumerian people in more than 5,000 years ago, and the very oldest examples of writing are basically, I think they're kind of IOUs. So it's something like John owes Bill 500 sheets of wheat or something. I find that funny that that's the kind of original use case for writing. We think of it now as a more like an art form, literature, that kind of thing. But yeah, that was the beginning of it. Moving towards more recent times, there are various. Writing was only invented independently a few times in history, but there are various sort of types of writing system. So you can have logographs, which are like Chinese characters, where basically a character will stand for a word, and then there's syllabaries, where a character would stand for a syllable. That's more like in Indian type or Brahmic derived writing systems. And then abecedas and alphabets, which is like the English type, where you have a character which represents a consonant or a vowel. And what you see often is that languages tend to adopt writing systems from each other. It was only invented independently a few times, and often the writing system which is adopted for a language is not really necessarily adequate for that language, because it doesn't have the characters which would cover all the sounds of the language, for example. So now we have things like the English spelling system, where the spelling and the pronunciation are not very close at all, and we'll come on to why that's really important for speech recognition, for example, coming up. Next slide. So yeah, once you have a writing system, moving into the kind of digital era, it's you also need a few more things to be able to show the characters on the screen. So the first thing you need is a kind of a character encoding. So since 1991, this has been done in Unicode. Basically, you have every single character in every alphabet or every writing system maps to a unique code point. And once you have that mapping, then you also need fonts and like rendering systems to be able to display these characters on on digital computer screens. And yeah, just to note that some characters, especially in alpha syllabary writing systems, are often made up of multiple code points. So you can combine code points to create like a unique character in a writing system. Next one, please. So yeah, once you have a writing system and a character encoding, it's possible to then develop smartphone keyboard layouts. So what's really great about the smartphone era is that we no longer need to design a physical keyboard for every writing system. We can just do that digitally, which gives us a lot more freedom to be able to support like a lot more writing systems and a lot more languages. So these are just a few examples of some of the keyboard layouts which were developed for the Gboard Android keyboard input method. We've got Georgian there, Bengali, I think. I'm not sure what else. Thank you. Next one. So yeah, smartphone keyboards don't just allow you to write one character after another. There's also a lot more like technologies driving them. So yeah, just a few examples of the kind of things that you can have in a smartphone keyboard. Autocorrect, so correcting bad spellings. You can also have next word prediction, which relies on language models, which we'll talk about later. So if you begin a sentence, it'll predict what word would follow. You can also have autocomplete. So if you have very long words, if you just type the beginning of it, it will boil it down to the only possibility and allow you to complete the word. Then you have kind of formatting type corrections, where if you don't get the capital letters right or something like that, it'll update the formatting for you. And then we have this example of glide typing shown, where you don't need to lift your thumbs off the screen to be able to type properly. And one fun kind of final consideration is if you're going to do next word prediction, you want to make sure that you're not doing kind of inappropriate predictions. So if you write, I'm going to my grandma's, you don't want to predict a funeral, for example. Maybe it would be house or something. Okay, next one, thanks. Yeah, then once a keyboard is in place, usually the next thing which is developed for a language is speech recognition. I'm going to talk a lot more about that, throughout the workshop. But just to sort of say briefly, speech recognition is basically the problem of trying to convert speech, so an audio representation of language, into a text representation. So transcribing basically what was said in an automatic manner. Next one, please. So yeah, like the kind of the inverse of that, which is usually the next thing which gets developed for a language, is text to speech, or TTS. And basically that's the problem of converting text in a language into a digital signal, which is a voice, like reading that text. And one important step in text to speech is what's called normalization. So in our example here, we have this text which is 12 minutes, but it's not necessarily obvious how you pronounce this 1-2 character. So you need to convert any kind of number or not word token into a version which can be then pronounced by the pronunciation lexicon, and then that pronunciation can then be converted into, or synthesized by the synthesizer into a digital signal, which would be a digital voice speaking back to you. Next one, please. Another thing which is in the pipeline for many languages is automatic translation. So this technology, you can take text or also speech if you have a speech recognition system in one language and convert that translator into another language. And automatic translation relies on large parallel corpora. So basically, large amounts of text which are being translated into two languages. And if we have that kind of parallel data, then we can predict how you would translate like a novel sentence. Google Translate supports about a bit more than 100 languages, but only it's worth remembering that only some language pairs are well supported. So, for example, English and most other languages, that pair is usually pretty well supported, but something like, I don't know, Swahili and Czech might not be so well supported just because there aren't many parallel corpora between those two languages, and there isn't that much need to translate between those two languages. So yeah, there's saying that 100 languages supported, like only some of the pairs of languages are really well supported among those 100. Next one, please. Yeah, usually the kind of the last word or the ultimate in language technology these days is smart assistants. So things like the Google Home or Alexa or any of the other major smart assistants. These are kind of actually what's behind the scenes, like a combination of different language technologies. So at the edge, when you talk to your smart speaker or your smartphone, it's using speech recognition to transcribe your voice into a written transcription. And then once we have your input in a kind of machine readable format, that is then converted into kind of what you want, what you intend to do. So an intent using a process called natural language understanding, or NLU. Once we have the kind of intent in a kind of format, then the action. Say for example, you want to set your alarm on your phone. The action will be converted into like an action on your phone, and the alarm will be set. And then it's also important to tell the user that the action was completed successfully. And for that, we use a process called natural language generation, or NLG. So it converts kind of what action happened into a natural sentence, and then we use text to speech to synthesize that written sentence back into audio format, so that you can hear I have set your alarm for whenever. And today these smart assistants are only available in around 30 languages total. And I think that's all for the kind of overview of language technology.
Hi, from Zindi. I see that there's some questions coming up on the chat. So I'm going to post one, Sandy, and I'm going to ask if you can answer it. You'll see it come up at the bottom.
Okay, the question is, doesn't having languages that are paired to English, but not between themselves, make it easy to have good translations between unpaired languages? Yes, that is true. You can use a sort of intermediary language to improve translation quality where you don't have much in the way of parallel corpora. But as I understand it, and this is definitely in my area, it's often a kind of bad filter. So features of the intermediary language will lower the quality of the translation from the source to the target.
Thanks.
Okay, I think we can continue on to the next section.
Thanks. So yes, for this next section, I'm going to look in more detail at kind of the background around speech recognition before the more kind of practical element in the next section, where Aliona, my colleague, will talk you through kind of how you might go about collecting data and building a recognizer yourself. So this is the kind of more sort of theoretical background behind speech recognition. So speech recognition is used for many reasons today. One obvious one is dictation, so voice messages, search queries, that kind of thing. So it's short form content. It's also used for more long form content, for example, transcribing lectures, or a really common use case now is automatically subtitling video content, for example, on YouTube. If you see the subtitles and the audio don't necessarily quite match, it's often that's the reason why, is because it's been done by an ASR system rather than a human transcribing the audio. It's also used in speech-to-speech translation systems, partnered with TTS and a translation module. So you can get from one speech in one language to speech in another language. And as I said before, in combination with other technologies, it's used extensively in smart assistants. Other uses include what's called keyword spotting. So that's when you listen to long stretches of audio, for example, radio broadcasts, and you look for keywords. For example, if you want to look for weather patterns in across a broad area, that one way to do it would be to look, listen to weather reports and look for keywords like rain or snow or whatever. And finally, the one which maybe people feel the least happy about is these telephone-based information services, where before you are able to speak to a human, you're often chatting with a speech recognition system which is listening to your voice and picking out keywords like yes, no, that kind of thing. Next slide, please. Yeah, before I go into the kind of technical details of how speech recognition works, I think it is worth remembering, why does this technology matter? What's important about it? And I think what really it does have a kind of social impact when you develop speech recognition for a language which didn't previously have it. One thing to remember is that it's a kind of ease of use question. It's so easy to be able to talk rather than to read and write. It's worth remembering not everyone can read and write for various reasons, and but nearly everyone can talk. So enabling speech recognition enables people to interact with technology using the modality, the language that they feel more comfortable with, which is usually their voice. Another important thing to remember is that it's really empowering for people. So it opens up the digital space to more people, especially marginalized groups, people who aren't necessarily in the major power structures of the community in various ways. And it's also an equalizing force. It has the power to lift up languages or lift up communities. Like it puts them on an equal footing with larger languages, with better resource languages. So speech recognition is a really key, important technology, a voice-first technology, which is the most important thing to say. Next one. Another thing to say about speech recognition before I go into the kind of technical details is that we're actually in a kind of a shift within the research around the technology, where we're moving from what's often called classic speech recognition, where you have these kind of three sub-models: the acoustic, the pronunciation, and the language models. That's what we're going to talk about next. But we're kind of moving away from that classic system towards a newer technology, which is called end-to-end, or E2E. You often see it written. And that basically only, in that system, you only kind of have one machine learning model, which will convert the audio like directly to text without these kind of intermediary or sub-models in the classic system. Next one. So yeah, I'll just talk about end-to-end models briefly. We're not going to go into too much detail because most of the open source technologies which are out there are still kind of our classic models. So just to say briefly, so end-to-end systems are a single neural network, so a single machine learning model. And one well-known type is what's called a recurrent neural network transducer, or an RNNT. That's a lot of words, but what those words mean are the recurrent element of it is that the encoder in the network is recurrent, so it is recurring as it's encoding the input signal. And then the neural network, it takes basically audio features and what was previously said or heard as its input. And then you have the transducer element, which basically rewrites those audio features and directly transforms them into written text. So you can get from speech audio signals to text with a single neural network. But yeah, as I said, we're not going to talk much more about that today. And I also, just to say that even RNNTs are a little bit older technology now. They're a couple of years old, and there are even newer end-to-end models like transformers models, for example, these days. But let's go back to classic recognition. Next one, please. So in a classic speech recognition system, what you have is these three sub-models, which are all kind of concatenated, composed together, and that creates the whole model, which takes you from audio, speech to text. So these three models, let's just say what each of them does. So first of all, the acoustic model is a neural network. And what it does is it's trained on transcribed audio data. So you have an audio track and a transcription of that audio. And what the acoustic model does is that it transforms or converts the audio signal into phonemes. We probably use the word phoneme quite a lot in the next 15 minutes, so it's just worth saying what that is. A phoneme is a kind of minimally contrastive unit of sound in speech. So something like per, ter, ker, b, d, g in English are phonemes of the language. So the acoustic model is taking the audio input signal and it's converting that audio input signal into phonemes, or let's say more specifically, a phonemic transcription of the speech. So basically every sound in the speech signal is converted into a phoneme, so a letter representation of that sound in the speech. So if I say cat, it converts the audio signal into these three phonemes, so k, a, and t. After that, you have the pronunciation model. So the pronunciation model is, quite, you can think of it simply as basically a huge mapping between these phonemic transcriptions, so the k, a, t representation of the word, and its spelled form. So you get from the phonemic transcription to the spelled form of the word. So we go from k, a, t to cat, cat. So that's the kind of the middle part of the system. And then what's really important is that there's a lot of potential, within speech for confusion, mishearings or mispronunciations or various types of, deficiencies in the input signal, which aren't, anyone's particular fault or anything. It's just like a natural part of what happens when you have this kind of messy input signal, which is like an acoustic signal, is that it's very possible for there to be multiple hypotheses for what the user said or was trying to say to the system. So we also use language models, which are usually n-gram models, and I'll come back to what that means later. And they're trained on large text corpora, so like hundreds of thousands or millions of lines of text. And what they do is they look at all that written data, and then they assign probabilities to sequences of words. So if I say to a system, I pet the cat, then acoustically that could easily be I pet the cat or I bet the cat, for example. But none of those other hypotheses are very likely sequences of words in English. You wouldn't necessarily pet a cat, or you wouldn't bet a cat, because it's just like nonsensical. So given the unlikeliness of those possibilities, we use the language model kind of like to assign probabilities to different hypotheses, and then usually we're much more likely to get to the most sensical transcription, which is often the correct one. Not always, but we try our best. So those are the three kind of major submodels. Next one, please. So yeah, just to kind of map that, if you're interested in the kind of more technical background behind it, to map those three models onto this this equation, which is the kind of theoretical construction of what an ideal speech recognition system would be. So you have the speech waveform as the input, and then that waveform goes through the acoustic model, converted to phonemes, goes through the pronunciation model, that the phonemes are converted into words, then the language model assigns probabilities to the possible transcriptions of the sentence, and then you have the output, the best hypothesis for the input audio. Next one, please. Another way to think about it, this is a nice way to conceptualize what a speech recognition system is doing. It's basically kind of, you can think of it as a kind of cascade of transformations on the input. So the original input signal is literally sound waves coming out of someone's mouth, and they're converted into a digital representation of those sound waves. And then in the very early stages, and this is not something that I'm particularly an expert about, but it's a really interesting process. That audio is basically converted into frames, which are very very thin slices of the audio, and it's looking in those thin slices for sort of really distinctive features of, say, a P sound or a T sound. Each of those sounds within a language has a very distinctive acoustic property. Can you go back? Thanks. And those frames are then they're subject to being able to be converted into kind of what's known as states. So that's what the acoustic model is really doing. It's taking these thin slices of the audio track and it's converting them into these states, which are basically it's a lattice. It's like a kind of hypothesis about how likely that sound is, that piece of the audio is matching this phoneme, this sound in the language. And then you have this phonemic transcription, and then the lexicon takes over and takes those phonemic transcriptions and converts them into words, and then the language model will take over and assign probabilities to the likelihood of these words occurring one after the other. And then after that you can also tack on or extend the output to even more sophisticated technologies, like using natural language processing to kind of understand like the meaning of the sentence, what people were intending when they said it, that kind of thing. But that's kind of like, that's why that arrow is dotted there. It's that's sort of beyond the edge of the speech recognition system. What we do in speech recognition is take the input audio and return you the best hypothesis of what the person was saying in the audio as a written transcription. Next one, please. So let's look at each of the submodels in more detail. First of all, the acoustic model. So what the acoustic model does, or what it takes as its input, is a digital representation of the original audio signal, and what it outputs is a lattice of phonemes. So the likelihood of each phoneme being the correct one for the input audio So yeah, it's never exactly certain, because of, audio conditions, people mispronouncing things, people talking quickly, running their sentences on, that kind of thing. So, we always have a kind of probabilistic analysis of what the phoneme in the audio is. So, so if someone says, yeah, bet, it could conceivably be pet, or they even meant to say pet, but they didn't say it right or something like that. So there's always a bit of uncertainty. And yeah, these days, these acoustic models are neural networks. But historically, there've been, speech recognition has been around for quite a long time, and there are earlier versions of the technology which were using things like hidden Markov models or Gaussian mixture models. So to train an acoustic model, you need lots of examples of input and output pairs. So to train any machine learning model, you need examples of what the input would be and what the output should be. So how we prepare audio and phonemic transcriptions, which is what's required, is you take audio data. So say you have an audio recording of me saying, "I pet the cat," and then we have a transcription of that data, and that transcription is actually nearly always written in the orthography of the language, the writing system of the language. And then what we do when we train an acoustic model is that we use the pronunciation model, so the lexicon, which I'll come back to later, to convert the orthographic transcription into a phonemic transcription. So you're kind of using, another part of the speech recognition system to prepare the data for the first part, which is the acoustic model. So what you have from your audio, transcription pairs is actually audio phonemic transcription pairs. So then when the data is prepared by the trainer, the phonemes, each phoneme in the transcription is kind of aligned with the audio, and then we use machine learning to see all these correspondences between the phonemes and the sounds in the audio track, and machine learning does its magic, takes over, and it starts to be able to predict where a particularly distinctive type of sound in the audio track will always correspond to a particular phoneme in the phonemic transcription. So there are some things that you can do to improve the quality of the acoustic model. Like, it's just worth saying, like, the acoustic model is really like the foundational part of a recognition system. Like, if you don't have good acoustics, like the whole system is really going to suffer, and it's not going to have the quality that maybe is required for whatever purpose you're trying to train it for. So some things that you can do to improve quality are to keep the recordings as similar as you can in terms of things like background noise, the clarity of the people speaking in the audio, any kind of like confusion of the kind of noise which is in the track is going to reduce the quality of the machine learning algorithm to be able to recognize the phonemes in the audio. Another consideration is length. So very long audio samples are unlikely to be correctly processed by the machine learning algorithm. So if you have long stretches of audio, it's worth thinking about possibly splitting them. So you can search for, there are methods for searching for silence within long audio tracks and splitting on that silence and keeping your audio as short as it needs to be. Another consideration is the diversity of the people speaking in your training set. So if you want a speech recognizer to be able to recognize the speech of people from all of the community, then you really need examples of all people from the community to be able to recognize those voices. So just for example, if you don't have any younger people, if you just have the speech of adults in your training set, which is very common, then it's going to be more difficult for you to understand and recognize the speech of younger people, children, for example, because it's just a feature of machine learning in general that if you don't have enough training data for a certain use case or domain, then it's not going to be able to perform well on that particular domain. But yeah, you've got to balance the diversity of the training set with it not being too diverse. So say, for example, when you're looking at a language, lots of languages have dialects or varieties, and if the language varieties have very significant differences, so they're not just a few words or one kind of pronunciation, if they're actually like maybe potentially different enough to be not really mutually intelligible all the time, then your machine learning algorithm, your acoustic model, is going to suffer, because it's trying to look at basically almost like two different languages. So you want it to be diverse enough to represent the entire community, but not so diverse that you're actually kind of dealing with more than one language's worth of data in a way. Pronunciation is key here. Obviously, the most important thing to try and keep as consistent as possible is the pronunciations of words in your training set are consistent. Then the acoustic model will become very expert at being able to predict words and pronunciations in the training data. Next one, please. So the next model is the pronunciation model, as I said. So the pronunciation model takes what the acoustic model outputs, which is a phonemic transcription of the audio, and it converts strings of phonemes, so sounds of the language, into spellings, the orthographic form of the language. So what you need to know for a pronunciation model is both the the phoneme inventory, so what are all of the sounds that are present in the language, and also phonotactics, which is basically the rules which govern which sounds can follow each other in a language. So for example, in English, you can have a sequence like str, like STR, in a word like string at the beginning of a word, but you can't have a sequence like, I don't know, ftring, FTR. That's not possible. That's an illegal sequence in English. So there are rules governing, not just how many sounds there are in the language, but how those sounds can also follow each other within a word in the language. And we use the phoneme inventory. They're basically like the output units of the acoustic model. So it's really important to decide and be definitive about those units, because if you show the acoustic model other units, or there are other phonemes present in the language which aren't in your phoneme inventory, then it's going to become confused and it's not going to be able to recognize those phonemes well. So once you've got the phoneme inventory and you've understood the kind of the phonotactics, the rules for your language, the next thing to do is to codify the grapheme to phoneme relationship. So that's letter to sound relationship in the word, and you'll often see this abbreviated as G to P. There are various techniques for doing it. One really successful technique is using finite state transducer type grammars, where you basically just have a kind of series of rules which are chained together, which will convert. We actually do it from spelled sounds to pronunciations. So you can, without having to, as I said before, your pronunciation model is going to be eventually a huge mapping, a big dictionary, basically, a lexicon of spellings and phonemic transcriptions. So one possible way to do that is literally just to sit and just type out the pronunciations for every single word in the language. But if your spelling system is semi-regular and you have a more or less regular correspondence between graphemes and phonemes, you don't really need to do that like manually. You can just write these grapheme to phoneme relationships and automatically generate the lexicon just by a few rules. And we'll talk practically. Oyeniran is going to talk more practically later about how you can actually generate that using a grapheme to phoneme mapping. One thing that's really, really important to remember when you're doing this is that not all languages have necessarily a very predictable relationship between spellings and pronunciations. So English is maybe one of the most famous cases of this. English spelling is often almost completely unpredictable. The way that a word is pronounced often has very little to do with the way that it's spelled in English. So I thought of a few examples. So here we have, Niger versus Nigeria. So that initial sequence, NIGR, is pronounced two different ways in two different words there. And then, another type of, confusing difference is when we borrow words from other languages, we'll retain the original spelling from the original language, which follows the spelling conventions of that language, but not necessarily the spelling conventions of the language, which is your target. So in English, we don't have this sequence DJ in Djibouti, but that's how it's spelled. So, and then another case is Lesotho, which I guess a lot of English readers naively looking at that word might say something like Lesotho instead of Lesotho. So if you have these kind of exceptions, it's really important that even if you generate your lexicon automatically, you need to go back into your lexicon and have a look for any of these kinds of exceptions and make sure that you update the phonemic transcription for these. So if we have a rule which is going to produce a poor quality pronunciation for Lesotho, for example, it's really important to go back in and correct that deficiency, because then when you hear that word in your training data, the pronunciation model is going to be able to do a much better job at mapping between what was pronounced in the audio and how that word is eventually spelled. Another thing to think about is there's two kinds of sort of variations within spelling. So first is what's called homographs. So that's when you have a spelled word, which can have two meanings and pronunciations, meaning pronunciation pairs. So a good example is these pairs in English where we have record, and that will be the verb where you have the stress on the first syllable, and then that written word can also be pronounced record when it's a noun, and then it has the stress on the second syllable. But when there's no signal within the written word which one it is. You just have to be able to, in your pronunciation lexicon, what you'd have to do is make two entries for that word, one as the verb record, and then another one as the noun record. So you have both pronunciations for that single spelling. And then another kind of variation, which is less systematic or less meaningful, is basically just what's called free variation, where some words can have more than one pronunciation. So the famous case in English is the word either can either be pronounced either or either, and there's no reason. It's not like a noun verb distinction or something. There just happens to be two pronunciations for that word. So it's also really important to remember to include both of those variant pronunciations in your lexicon. So to summarize, you can do 90% or a large amount of the work using a GTP mapping and generate like nearly all of the lexicon automatically. But then it's really worth spending a little bit of time going back through and looking for these exceptional cases, these non-standard spellings, and refining the lexicon a little bit to get you closer to the real relationship between the spelling and the pronunciation. Next one, please. So the final step in the process is the language model. And the most common kind of language model, which is used in most kind of commercial speech recognition systems these days, is what's called an n-gram model. So it's a bit of a strange term, but what this means is you have, so in our example, we have, I said to the recognizer, I pet the cat. And in that sentence, we have bigrams, which are I pet the, and the cat. And then we have trigrams, which are I pet the and pet the cat. And then a 4-gram, which is I pet the cat. And then, if it's a longer sentence, you can have 5 grams, 6 grams, and then n-grams. So that's why it's called an n-gram model. So these grams are sequences of words, subsequences of words within the longer sequence of the sentence. And what the language model is really good at, and what it's able to predict, is which are the most likely bigrams, trigrams, n-grams in a sequence of words. So if you say something like, this is a classic example from the literature, if you say recognize speech to recognizer, it could conceivably be recognized as rec a nice speech instead of recognize speech. But because rec a nice speech, it's just not something that is like, very likely, that anyone would say, and you're not going to find it in many, examples of written English, then we're much more likely to pick the second example, which is the correct hypothesis, than the first example. So that's what the N-gram model is really good at doing. And the way you train the language model is you don't need audio data. You don't need audio transcription pairs to train a language model. You just need text data, which is really not all that difficult to find on the web. And Oyeniran's going to talk a little bit later about how you can practically go about finding data for your language model. So one really important way is to look for self-identifying sources. So for example, the Wikipedia page or the Wikipedia in a language, you can pretty much guarantee that all of the the pages on that whole website are going to be in language. And then another technique is to use what's called LangID, where you look for, I think sometimes they're called shibboleths. So it's words which really distinctively only occur in the language that you're interested in. And once it's found a few of those on a web page, we can say with a pretty high degree of certainty that that page is probably in that language. So those are two techniques for sourcing text corpora for a language model. Once you've got the data off of the web, and the web is by far the best resource for text data. There's it's almost inevitable that there's going to be quite a lot of junk, basically not low quality, not in language, things like lines which are just someone's email address, or I don't know, just a sequence of punctuation symbols which doesn't have any real language data in it. So a really important part of the process of getting good quality data for your language model is to use text normalization to clean up your data. Again, the FST grammars are a good way of doing this. So what you really want is to remove kind of differences in the data which are going to standardize the way that the language looks to the language model. So if it sees like a word which is spelled with all uppercase letters or all lowercase letters, it's going to think that they're two different words. But so they're not really. So you want to be able to standardize that uppercase variant to the lowercase variant. So a good technique is just to literally like lowercase all of the words in the whole data set. And then, as I said, like remove junk, get rid of, things which aren't really in language. And punctuation is often, not very useful because, if it sees, a word and it has a full stop attached to it, and then the word in the middle of a sentence, it's going to think that they're two different, tokens, but they're not. You just want to remove that, that punctuation symbol from the end of the word. But a word of warning about punctuation. If we can just go back one slide. So there's this place in Chad called, I'm sorry if I mispronounced this, and Jemena, and there what's important to notice is it has an apostrophe, but that apostrophe is not a punctuation symbol in this case. It's actually a part of the spelling system of this language. So you wouldn't want to just blanket remove all apostrophes from your data. You want a more kind of contextual rule, which is going to remove apostrophes which occur after a full stop or at the end of a sentence or something like that. Because if you remove symbols which are actually part of the spelling system of the language, you might be missing an important clue, and your language model is not going to match up with your pronunciation model and eventually your acoustic model as accurately as it might otherwise. So it's just important to keep that in mind. Next one. Can we go back? Thanks. Oh, sorry. Can we one more point on language models? Another really important consideration with language models is that whatever data you've sourced from the web for your language, the words which your speech recognition system will be able to recognize are only going to be those words which are in your data. So if there's what's called a out of vocabulary item, or sometimes called an OOV, then your system will not be able to recognize that word. So, it's important to keep in mind that languages change all the time. There's constantly, new words appearing, and also words dying away, but that's less important. As we all know, in the last couple of years, a large, new vocabulary has basically come about to deal with, or to talk about, the things which have happened relating to COVID and vaccines and things like that. But if you don't, refresh and keep your language model data up to date with what's going on in the world, then your system is going to slowly get worse at recognizing what people are saying to it. So yeah, it's just another consideration that you need to keep up with and retrain your language model at semi-regular intervals in order to be able to recognize what people are really talking about today. Next one. So yeah, the next thing I'd like to talk about is it's more of a kind of it's kind of a subtopic within language models, and it's called verbalization. So the process of verbalization is dealing with what I talked about a little bit at the beginning with text-to-speech, which is that you have these so numeric tokens, so things like this euro sign 5, which would be said as 5 euros, and then we have this 13:30, which might be said as you could say it as 13:30, but people might also say it as 1:30, 1:30, that kind of thing. And then you also, so those are like numeric tokens. Then you also have these tokens which are very special, which are called not a word tokens, and that's things like URLs, email addresses, where you have symbols within the token which actually do have a kind of pronunciation. So google.com with a Google with a period and then com is actually pronounced google.com. So it's not very good. Well, it's not really feasible, in fact, to just list all of these tokens in your lexicon, because even if your language model training data has 5 euros and 10 euros, what if it for just because you didn't find a page which has it, it doesn't have 553 euros. So that token is not going to be in your training data. So and therefore you're not going to be able to recognize it. So one really important process in like preparing your language model training data for training, to be able to train the language model, is to go in and like look for these tokens and convert them into something like what we've got here. So instead of euro sign 5, you have the sequence 5 euros. So it's still a written form. It's still a written form of the language. You've converted this token into a sequence of words which are much, much more likely to be in your lexicon. So or they will be in your lexicon. So you have a chance of recognizing them and getting them right. I just thought just to give an example of the kind of this is not a simple problem. It's a whole kind of issue in and of itself in a way. So to just give an example of a kind of a slightly complex case, which is from Hausa, which I think is maybe one of the languages which we're going to be looking at in this workshop. So this is how you say, so if you look in the first column, sorry, in the first row in the second column, so this is how you say, and please correct me if this is not correct, this is how you say 234 in Hausa. So what's really significant and important to remember about this particular case is that what we have here is a difference between what's called spoken and written factorization of the numbers. So in the written form, what we want to get to is 234, so which is really 234. But what we have in the spoken form is a different word order than or a different kind of order of factors than what we have in the written form. So instead of 200, which is what we have in the written form, here we have 102. So that's how it's spoken in Hausa. So what you need to do to deal with this kind of token is a kind of a series, a cascade of transformations on the input so that you will arrive at the correct output. So the first thing to do is to convert all of the words in the spoken form into numbers. So yeah, this is a bit confusing, But when we do text, so speech to text, so speech recognition, we actually write these grammars in the opposite order. So we go from the spoken form to the written form, which is what we want to do. So you convert all the words to their numeric form. So we get from 100 to and 30 and 4 to this output, which is in the third column in the first row. And then what we need to do, which is a very special step for Hausa particularly, and many languages, I think lots of sub-Saharan African languages, especially Bantu languages, have this property, is that we need to invert the multiplicand. So you need to flip round the 100 and the 2 so that it's written in the right order as the written form, in the same order as the written form. So from 100 to and 30 and 4, we get to 200 and 30 and 4. And then once you've done that step, then it's possible to do the multiplication of the two multiplicands, the two factors. So we get to 200 and 30 and 4. Then we're going to remove the and word because it's not really part of the arithmetic. So just from 230 and 4, we get to 234. And then the final step is just to do addition, to remove these zeros, which we don't really need. And then you get to the output, which is 234. So you can see how, even in this very simple case, which is just a cardinal number, you need at least 4 or 5 steps to be able to convert the written to the spoken form. And now imagine, in your data, you have something like 234 euros or $234. Then you need to do all this for the cardinal number, and you need to remember to, convert that currency sign and also move that currency sign to the end of the sentence. So verbalization can quickly become, very complicated. It's not necessarily central to every system, and not everyone does this. It's just like a deficiency of some systems that they don't really handle this. But I thought it was interesting to talk about it, just as a kind of way of improving the quality of your recognizer. Next one, please. We're almost at the end of this section. One thing that I'd like to talk about just before we close and go to the Q&A is, I guess, the theme of this workshop and, the theme of my work and many other people's work is, what do we do in cases where, we don't have very much in the way of publicly available, training data for ASR systems. So there just isn't very much of this audio transcript pair and also text data, which you need for the language model. So there are various techniques which you can use to improve the quality. So one thing you can do is what's called semi-supervised learning, which is where you use just a small amount of transcribed data. So sorry, in machine learning, these words supervised and unsupervised are often used. So supervised data in the ASR world is transcribed audio, so audio transcription pairs. And then unsupervised audio is just audio without any transcription. So as the semi-supervised learning technique is to use a small amount of transcribed data and then a very large amount of untranscribed data, so just audio that you found in the language. And it's possible to achieve pretty good results even when you don't have transcriptions, because you train a sort of lower quality model on the transcribed data, and then you use that lower quality model to kind of automatically transcribe the unsupervised data, and then that's good enough then to bootstrap the entire model and be able to improve the quality of the entire model. I found a paper which I found quite interesting where Biswas and all worked on this for Somali, and they've got pretty good results with a very small amount of labeled data. Another interesting technique is what's called multilingual modeling. So in this scenario, what you do is you take the small amount of transcribed data that you have for your target language, and you pool that data, or you pool that data together with data from other higher resource languages, which hopefully have similar acoustic and lexical properties to the language that you're interested in. So say, for example, you're working on a low resource Bantu language, maybe you could pool your data with what's available for, say, Swahili, which is a lot more than other languages. And because the there's some sort of both acoustic and also lexical similarities between the target language and the higher resource language, then there's some transfer of knowledge from the higher resource language data to the lower resource language, and you can bootstrap your ASR system for the low resource language using this data, which is not really in language, but it's kind of close enough that it's able to, because at the very early stages, there's just very general properties of both languages, which the acoustic model, for example, can learn a lot from. So for example, every language has consonants and vowels. And then if you have similar consonants and vowels, it can do a lot of like the learning from the other language, the higher resource language, versus the language that you're interested in. And then the final thing I'd say is, there's a lot of focus on these kind of interesting and novel machine learning techniques, but really, like, the most important and most definitively the best way that you can improve the situation for a low resource language is to make it not a low resource language anymore. So that's kind of what this workshop is all about, really. It's so important for us to just basically start to build like sustainable and open source resources which are available to everyone, so that everybody can benefit from everyone else's work. If we pull together the efforts of many people, not everyone has to spend large amounts of time preparing all this data, but everybody's contribution can lead to a very large and usable data set that everyone can use to train acoustic models or to train ASR systems generally. And like the possibilities of what you can do with that data aren't necessarily limited to just training speech recognition systems. There are many applications, even applications that we might not know about today, of using this data for all kinds of purposes. So yeah, my final thought is to hopefully impress on you the importance of data collection and data curation as really the foundation and the cornerstone of all of these other efforts. Without good quality, usable and open source data, we won't be able to proceed. And with that data, we will be able to proceed. We will be able to produce and generate workable and usable speech recognition systems and other language technologies for many, many more languages all around the world. And yeah, that's sort of my closing thought. I guess we'll move to the Q&A.
Hi. So I'm going to start dropping questions here for you, Sandy. Some of these questions you've answered already.
Okay.
If you could just reiterate them, that would be great.
Sure. Yeah. No problem.
So this is from Mr. V. How do you overcome translating from a language like English, which has a large vocabulary, towards a language whose vocabulary has not been developed in certain areas, like sciences?
Yeah, it's a great question. So I think often the case where you have a language which is not necessarily doesn't have vocabulary in a particular domain, is what you'll find is that when that domain becomes used or important in that language, then a process of borrowing assimilation of words from, say, English or any other language of contact would take place, and then the vocabulary would be largely from English or whichever other language is the language of contact. But yeah, like I do know that about some work on this in this area that some people have been working on developing scientific vocabulary for languages where that's not necessarily extensively developed. That's another way to kind of to intervene and to proactively develop a new vocabulary for a particular domain.
That's really interesting. Thank you. Next one is from Dada. Considering I have a local language that's not available on Google Translate, what steps do I need to do to translate it? And how can Google use my language model?
Yeah, great question. Translate requires on these parallel corpora. So one important step to take would be to develop those parallel corpora. So provide lots of examples of translation pairs between the language of interest and the language that you'd like it to be translated into and out of. And yeah, those resources, they are picked up by tech companies generally, and they are used as part of the training data. But yeah, what I would maybe comment on, and translation isn't really my area, I'm more in speech recognition, is that you need huge amounts of training data to train a good quality automatic translation system.
Thanks. Next we have one from Umar. Can you please give an example of an acoustic model implementation for a low resource language?
Yes, perhaps we can make the links on the slides available. So yeah, if you look at the paper that I linked to, there's a good example for Somali of an acoustic model which has been trained without much in the way of supervised training data.
Great, yes. All links provided by Zindi and the rest of the Google team will be made public once the hackathon goes live in 2 hours, I think, so stay tuned. We have a last question from Mr. B. When designing your language model, how do you deal with code mixing or switching?
Yeah, it's a great question. I think this is really sort of language-specific kind of consideration. So if it's the case that language code switching or code mixing, which is, in case anyone doesn't know what that means, it's where you kind of switch languages either within a sentence or like across sentences. If that is like a really prevalent feature of the language uses of the community, I think it's possibly not a terrible idea to like not do much about it, leave it in there, and make sure that your acoustic model and your pronunciation model are able to deal with it. Although yeah, I do see the issue where you're basically trying to create a kind of like hybrid model there, which is basically dealing with speech from two different languages. Yeah, like I think it's quite a language specific question, and there's really there's a large difference between, say, a language whose vocabulary is primarily from the source language, and then it uses, say, like we were talking about before, say English words for certain domains like scientific concepts or things like that. That's more like a kind of case where it's more borrowing, and yeah, there it's quite easy to kind of deal with in the lexicon and in the language model. But yeah, where you have this situation where it's literally like the community speaking two languages, or mixing two languages, it is more complicated. And there's some interesting work which has been done, for example, on what's sometimes called Hinglish, so Hindi English speakers in India, where they mix between Hindi and English. And yeah, you can find lots of papers on the sort of special techniques which have been developed to handle that kind of particular language use situation.
Thanks. Next is from Monsina. How can we deal with diacritics? This could be interesting to ask both from a ASR perspective and we did a Google Translate one, but an automatic speech recognition diacritics could be cool. Yeah.
So yeah, so as I understand it, so maybe it obviously the diacritics are used for very different reasons in different languages. But as I understand it, in many sub-Saharan African languages, we have acute and grave accents on the vowels, and they indicate tone. So you have high and low tone, or sometimes high, mid, and low tone. And the situation is that in some languages, they're used very consistently on every vowel to mark every vowel as high or low tone. And then in other languages, they're only used where the written word would otherwise be ambiguous. So they're only used to disambiguate otherwise ambiguous words. Then you have other situations where there is tone present in the language, but tone is not marked in the orthography. So in each of those cases, it's possible that you need to do different things. So take the case where tone is consistently marked on every vowel. As the most important thing to do then, I think, is to do some serious QA, quality assessment on your data, and make sure that the tone marks are consistently matching the tone in the audio track. Because if you have mismatches between the tone marking and the actual tones which are present in the language, then the acoustic model is going to become confused and not be able to handle the mapping between tone, the realization of tone in the speech and the marking of tone in the orthography. Where you have, in the case where you have tone marks which are only used to disambiguate words, again, yeah, it's a case of making sure that they map accurately, and there is an argument, say, to take them out, to remove them, and just produce toneless transcriptions, because in your lexicon, what you're going to do, what you're going to derive is, say, you have the same word which is sometimes tone marked where it's ambiguous, and then in other cases not tone marked, and it's going to think that they're two different lexical items, but they're really not, right? They're the same word. So yeah, there's a case for stripping tone, or to go the other way, to restore the tone marks in every possible word, like on every single vowel in every word. So you'd have to go through and find some technique to restore tone marking in the orthographic form. And yeah, in the case where you don't have tone marking at all, but there is tone present in the language, I think there are other cases where you have like acoustic properties or features of the speech which are not marked in the orthography. So I'm thinking of different examples, like something like even like Chinese or something. So there you have like very little correspondence between what each letter corresponds to in the speech track, but it is still possible to produce to train a model which can do the the mapping between speech and text in that case. So in the case where you have tone but you don't have tone marking, it's probably fine to just not that's the reality of the orthographic situation. Just don't include it also in the training data. I hope that answers the question. I don't know. I talked quite a lot about tone marking because I think that's the special use of diacritics in many sub-Saharan African languages, unless there's other use cases for diacritics.
I'll keep an eye on the chat in case there is a follow-up question. This is from K Apps. Is there a benchmark for the word error rate for low resource languages?
Thanks. No, I don't know. I don't think so. For many languages, there are no ASR models available at all. So currently, if you like, the word error rate for those languages is 100%. So we're not doing anything. So anything that you do to improve on 100% is an improvement.
Can one use no spelling checker to improve an ASR model?
Thanks. I'm not sure what NER refers to. Is that a kind of spell check?
It must be. K-Apps, maybe you can expand in the comment section and Sandy can respond there.
I'm getting it here. It's named entity recognition. So I think we're talking about two different things. So named entities are a particular problem because usually things like place names and people's names have sort of special orthographic properties, like they don't necessarily follow the spelling conventions of the language, and also they're not very common in the training data, so we're much less likely to get them right. And so I guess like there are techniques to kind of optimize for that and make sure that you're including these special cases as long as they're present in the language model training data and you have them in the lexicon. Then it's not so likely that you're going to get them right every time, but you can like increase the likelihood with some extra work. Spell check, I guess it's a form of normalization. So you're basically standardizing non-standard spellings or alternative spellings to kind of one standard form, and that would definitely improve word error rates because you're removing some variation which is not useful for your model. So you're just like basically standardizing on one form. One consideration I would say with that is which form are you picking, because maybe, you know, spelling variants don't necessarily, there's not always like a very simple, like this one's right and this one's wrong. Maybe like one spelling variant is used by a different community or a different, you know, group within the community, and you might be sort of standardizing towards one form and not the other if you remove any kind of variation like that. So yeah, it's just worth keeping that kind of thing in mind.
Thanks, Sandy. That's all the questions we have for now. Connie, do you want to take over?
Everyone, we're going to have a 5-minute break right now, and we'll reconvene at 52. Hey everyone, welcome back. We're going to jump into the next section with Elena on data and data collection.
Hi all, and welcome back everybody from the break. My name is Alena, and I'm also a linguist at Google, and this is such a pleasure to be speaking to you. So yeah, here today I will cover the topic of data and data collection for ASR, something this is quite important for the topic of this hackathon. And just to reiterate myself and everyone else on this workshop, data is crucially important for speech recognition systems. Since the successfully trained ASR system takes audio files or sound waves and translates them into written text, this is exactly what we need to train such a model. Files with audio and files with their transcriptions, so with their textual transcriptions. When we're working with training ASR models, training and testing are two separate processes, and they require separate data sets. So one data set will be fully dedicated to training, and another one to testing. And here I'm ready to answer the question of some of you on the chat that popped up recently. So the question was, what's the minimum amount of data that we need for training? So of course we want as much data as possible, but usually the training data that's less than at least 2 hours doesn't produce high quality result. And as of the testing data, we need at least 1 hour to have reasonable assessment of our model. But assuming that we have a little bit more than just a tiny bit of data, the rule that you might have seen in other parts of life is 80-20, so it applies here as well. We want to dedicate 80% of the data set to training, and the 20 will go into testing. And something that's crucially important is that no data should be shared between testing and training data. Some of you might be familiar with overfitting, so this is exactly what might happen. So basically, if we train and test the model using the same data, we will not assess it reasonably, because the testing data should be completely novel. And yeah, just one more point to say about this part is that if we really don't have enough data and we want more and more examples, we can involve examples from other languages as well. Ideally, they will be related, but also they can be just acoustically similar. Next slide, please. So this is another crucially important topic when it comes to data. Sandy already covered it slightly, so let me go and reiterate on this as in that. We want our data set to be diverse and representative of various speakers, regions, conditions, and so on. So first of all, various speakers. We really want to make sure that our model that we are training will learn how to abstract from the voice of a particular speaker or just a small group of speakers. And for this, we need to make sure that various speakers are represented both in training and testing subsets of the data. Also, we want to make sure that we include various ages and genders, so that people of various age groups and genders are also represented. Their voice qualities are a little bit different. The lexicon might differ to some degree. So we really need to ensure that the data is diverse in this way as well. And as you, I'm sure, know, language differs depending on different parts of the country or the world. So if there are different dialects in language, we do want to include examples from different dialects and from different regions of the country as well. And we already discussed it, but of course, it's very important to have various words and topic represented. As Sandy already explained, only the words that our model saw during training will be able to be recognized later on. So we really wanted to make sure that the topics and words are diverse in the training data set. And lastly, various conditions. So it might be not very complicated to recognize speech in a very quiet environment, but we want to make sure that people are able to use our ASR systems when they're on a train, when the dog is barking, when the plane is flying over, and so on. So also in the training data, we do want to include recordings that are made in various conditions. Next slide. And when it comes to ASR data, I would like to mention one of the biggest sources and open source available data sets. It's Mozilla Common Voice. It's one of the largest collected multilingual data sets of spoken data. And if this reminds you the browser Mozilla, it's actually the same team. It's the same group of people. And they created Mozilla Common Voice. It's slightly gamified way for speakers of different languages to submit their data. And then it's all open sourced, so people are actually able to use this to train their models. And actually, some of the languages spoken in Africa are already available as part of Mozilla Common Voice. So they are Kinyarwanda. Actually, this is a fantastic example, also previously mentioned. There are 2,500 hours of data available for this language. So language Kinyarwanda spoken in Rwanda is actually not a low resource language anymore in the sense of this acoustic data. Then there are some other languages such as Kebale and Luganda and Hausa that are already available in Mozilla Common Voice, and some others are also on the way. So for example, Swahili and Igbo are joining those 4 languages soon as well. Next slide, please. And here I would like to answer another question that earlier popped up on the chat. So how do we actually, what are the sources of data that we can use to collect more speech data for low resource languages? So one of the approaches will be elicitation. So basically, if you have access to a speaker of the language data for which you're collecting, or if you are that speaker, you can just record yourself. And you can record yourself either reading certain paragraph or speaking spontaneously. So there is a crucial difference between read speech and spontaneous speech, because read speech tends to be a little bit slower, more enunciated, and it differs from spontaneous speech. That's faster. There are some corrections, such as when the speaker starts to say another phrase and then they decide to switch the phrase a little bit, and so on. So for read speech, usually the speakers are provided with text snippets. We also call them prompts, and then they are just recorded reading those snippets. And for spontaneous speech, it's easier to prompt speaker to speak using an open-ended question. So something like, what's your favorite food? What was the weirdest dream of your life? And so on. And then you take their answer and you record it and transcribe it. But of course, there are some other sources as well. And other sources include transcribed phone conversation, podcasts, movies, videos, and so on. So next slide, please. And when preparing data for training and testing ASR models, I would like to highlight one big problem. It's called transcription bottleneck. That the core of this is it takes 40 minutes to transcribe 1 minute of audio. And it's a lot of resources that usually go into transcription. And that's why, next slide, please, it's quite important to sometimes just rely on text prompts. So when we rely on already existing textual data to produce the recording, we don't need to transcribe it, right? Because we can just assume that what's being said, it's exactly what's being written. So we can just use text data and record it, and then we don't need transcription. So to do something like this, it's good to just look for available text corpora in your target language. Zindi explained how this is usually being done, and I will just repeat this, that it's possible to use Wikipedia dumps, different web crawls, and so on. So basically, there are various ways to identify text in the target language on the internet, and then you can just record it, and you don't need to transcribe it in this case. And it's also quite important to do quality control when working with the data. So we would like to throw out poor quality data, so non-language data or data with some other types of issues. And also, it's better to split the data into shorter parts. So, for example, into sentences, and you can use punctuations as a guide. So, if there is a very, very long chunks of text and you're preparing the training and testing data for ASR models, it's better to take all these long paragraphs and split them into sentences. So, shorter is better in this case. Next slide, please. And talking more about data collection part, we wanted to share with you an app that's called Gesicho. It's an app that can help you to prepare text prompts. So this is it runs on Android phones, and it allows users to simplify the process of spoken data collection. There is extensive and well-written documentation available for this app, and I just want to cover the user journey just a little bit. So the main features that this app provides are recording, or speaking, translating, and elicitation. So recording is just straightforwardly recording spoken speech. Re-speaking is when you already have the original recording and you would like another speaker to pronounce it. Translating, obviously just translating recordings from one language to another, and elicitation, something that we are going to be using for this hackathon, is using various materials to create voice recording. And in general, there is a wide variety of the materials that you can use to elicit voice recording. It can be text, something that hopefully we will be using in this case. So you have text and you're asking a person to read this text. It can be an image. In this case, the speech will be a little more spontaneous. So for example, you're showing the speaker an image and asking them to describe this image in their native language, or also video. So something similar to the image, like you're showing them a video and you're asking to describe it and summarize it. But yes, again, that for the purpose of this competition, you can use elicitation by text, and it will hopefully help you to simplify the data collection. Next slide, please. So just a couple of technical details. The Gesicho app, you can install it using the APK file, and you can get access to it on the Zindi platform. So just connect this to your phone and install it from the APK file. And to use textual prompts to collect acoustic data, you need to prepare a text file that will contain those prompts. So it will look like something like this that you're seeing on the screen. You will need the collection of sentences in the target language, and then optionally you can provide a translation. So if you want to provide a translation, then on every line you need to put a sentence of the target language. After that sentence, put space, # space, and in case you do want to provide translation, then end that line with the translation. But translation is not necessary here since it's outside of the scope of the hackathon. So you can just use the text in the language for which you're collecting data. Just please make sure to end each line with space, # space. This is crucial, and this is the type of the textual file that will be read by Gesicho app, and that you can work with it further. So yeah, whenever you have prepared all the prompts, you should save them in a single file and transfer it to your phone. Next slide, please. So if Gesicho app installed successfully, this is so it will open and you will see the screen something like this, and it will open right away and you will be able to access the elicitation option. So elicitation is exactly something that we'll be doing. So click elicitation, and then to use elicitation by text mode, select it. In this case, you will be able to collect audio data using text prompts. Next slide, please. So if you click on elicitation by text, it will prompt you to create a speaker profile. So in this profile, you should put information about the language and the speaker. So what you want to highlight is, of course, which language is being spoken. And you do want to differentiate different speakers, but also please feel free to provide all the information that might be important, such as age, gender, region, where the person grew up, and so on, right? So all these factors shape the way we speak, and it is very helpful to keep track of them as well. So when you filled in the questionnaire that will ask you to describe the speaker and click on proceed, it will generate a consent form for you. So let's talk about this for a second. So for any study that you do, it's actually very important to practice ethical research and get the consent of your participants. So you want to explicitly inform your participants about what's the purpose of the study, why are you collecting their data. You want to highlight again that the participation is voluntary. Let them know that they will be recorded. And of course, for acoustic data collection, that's a pretty crucial step. And what will happen with their recordings. So for example, you might want to explain them that there's this project where you would like to collect spoken audio data for this language and use it for training and testing ASR models and so on. And I'm sure that participants of your research will also be just very interested to know more about why you need their acoustic data. So yes, after you enter the speaker information, it will generate the consent form, and you should sign them, the consent forms with the speaker. And when this setup is done, it will prompt you, and you can select the file that contains the prompts, the text snippets that you selected to be recorded. And that's it. As soon as this is done, the next screen will show elicitation text, and it will give you that small screenshot that you see on the right part of your screen. You will be able to start collecting the acoustic materials. So start recording the audios and skipping it to the next one and so on. So you will be able to start collecting the audio data. This ends this section. Please let me know if you have any questions about data, data diversity, or the LIGIQ map. Thank you.
Brown.
It looks like we don't have any questions at the moment.
Okay, this sounds good.
Yep.
We can just proceed to the next section and talk more about model training. So, next slide, please. So let's talk about various open sources, ASR engines, and APIs. There are quite a couple of them, although not too many different engines and APIs that you can find for training ASR systems online. And first, I want to highlight the difference. What's the difference between an API and an engine? So when we say engine, we mean something that provides basic structural elements of an ASR model. So acoustic model, pronunciation model, language model, and all those parts will be part of the engine. So very crucial basic structural elements. But APIs, it stands for Application Programming Interface. They simply access, it's just something for us to access and control those engines. So adjust different parameters, for example. And if you search, there will be quite a couple of different ASR systems that you'll be able to find online. I have a small list of them here, but can we please switch to the next slide and look at a couple of them in that? So first of all, let's take a look at LPs. I will not spend too much time on it here because the remaining of this section will be showing how to prepare data and train ASR model using LPs. But this is a relatively user-friendly tool that's developed in University of Queensland in Australia. And talking again about the topic of how much data do we need to train a model, this can train speech systems with very small amounts of data. So for example, there were some experiments when we were training ELPIS with as little as 1 hour of data, of audio data, and it was already showing some meaningful results. Another engine is Kaldi, and it's actually one of the tools that runs underneath ELPIS. So it's written in C++, and it's quite old, and it focuses on non-deep learning methods. So something like hidden Markov models, finite state transducers, and others. And just some cute fact from Wikipedia is that the name of this app is Kaldi, and it's actually named after the Ethiopian goat herder Kaldi, who was said to have discovered the coffee plant. So that's an interesting fact, something a bit personal about that engine. And just a couple of other examples. It's Mozilla Deep Speech. It's a more modern deep learning engine with a beautiful Python API. NVIDIA Nemo. NVIDIA Nemo is not exactly for just ASR. It's actually a toolkit for various language-related tasks. So it has the ASR part, but also NLP, TTS, text-to-speech modules, and some others. And if you will do your own search, I'm sure you will see some other ones, such as TensorFlow ASR, WAF2Letter++, and some other ones as well. Next slide, please. So let's focus on ELPIS here. So ELPIS is a tool that simplifies access to training ASR models, and it's an ensemble of various technologies. So first of all, it runs on Kaldi. It's an ASR engine, as I already mentioned, with mostly non-neural models. Then there is ESP.NET with neural ASR models. Then it also includes Hugging Face, and Hugging Face, you probably heard of it. It's a library of novel machine learning and NLP methods. So this is the part, those three are responsible for the ASR part of it. And then to make the software executable, it's wrapped into a container so that this code can run on various infrastructure. So this is done with Docker, and overall the language of ELPIS is Python. Next slide, please. So let's look at how to operate with, how to use ELPIS. So here you can see two parts of the pipeline. One is vertical and one is horizontal. So the vertical one is highlighting how the training happens, and the horizontal one, the one that you see on the bottom is just operational input. So like, how do you use already existent model? Let's look at training first. So to train ELPIS model, you need three types of files. You need audio, text, and LN files. You're probably wondering what are the LN files, and I will cover this in a second, and also how you produce them. But basically, LN files is something that helps us to align text and audio. Right, so like it's just a file that provides like time markers, like where each word starts, for example. So as soon as you have those three types of files and input, conversion happens, and two different types of files are produced. One is clean audio, so audio is cleaned from like everything else, and the other one is JSON file. It's just a summary of different metadata and everything that's related to transcripts and timings of the transcripts. So it's just a file with metadata, and then two other important components of ELPIS is normalization rules. So this is something about like how exactly do we spell different things, right? So like if we say COVID-19, for example, we do expect to see the dash between digits 1 and 9. So like that's a simple relevant example. And also pronunciation rules. We will take a look at it again in a second, but this is more like how do we pronounce things, and how do different pronunciations map to different spellings in the language. So these all creates an acoustic model, and together with a language model, right? So again, acoustic model is a pronunciation model that comes via pronunciation rules. It's something that tells us which audio waves, which parts of the audio are mapped into which phonemes. And then language model is what describes us what words exist in this language, what is the distribution of these words, and so on. And all together, this produces an ASR model that then we can use to recognize audio. So how do we do that? The operational input is audio. We just need audio files to recognize them, right? So we pass those audio files into the ASR model. It produces an FST, finite state transducer, that basically lets us know what different recognition hypotheses there are. And then we just pick the most likely one. And this is our transcription hypothesis. Next slide, please. So just a couple of words about the quick guide of ELPIS. So what we are showing here and what I will be showing in the following slides is adapted from the slides by Wiles and Foley, where they were also introducing participants to ELPIS ASR engine. And of course, we will provide the links as well on the Zindi side. So yes, we will walk you through the preparing data and how to set up a pronunciation model. And it's not really necessary to use ELPIS for your submission. This is just an example, but of course you're free to use any different training method that you would like. And also the challenge Intro to ASR Africa, it will start on February 14. We will by that time provide in-depth tutorial video on how to use ELPIS, and it will be available in the data tab section. Next slide, please. So first of all, let's talk how to prepare the corpus to be used by ELPIS. You need to start by having clean audio and orthographic transcriptions. And it's better to have utterance or sentence level segmentation, so not just like word or phoneme. So keep sentence. Right, like when you were preparing the file for elicitation using LigIQ, it was one sentence or one utterance per line. So it's also good to have the corpus in the same shape. And the step that's specific to ELPIS is that you need to convert TXT transcription files to ELAN format, because this is one of the types of files that's required for training. And this can be automated. So there is a Python script, it's linked here, but of course the link will be available to you as well. You can just run that Python script and it will produce ELAN files for you. You will see them, they have EAF extension. So yeah, they will be available for you as well. And finally, good corpus for ELPIS needs to have a parallel data of matching file names. So you need to have, so if you have a WAV file with a certain name, you do want to make sure that TXT and ELAN EAF files will have exactly the same name. So file one will be file1.wav will have also file1.txt, file1.eaf counterparts, and so on. So just repeating that, please make sure that you have matching file names of your audio files, textual files with the transcriptions, and ELAN files. Next slide, please. So yes, something else that needs to be created for ELAN to work properly is to create a pronunciation lexicon. So it's just a file where you outline rules that map orthography to phonemes. So basically what you see written and what you hear pronounced. And these will be further on used to build the pronunciation lexicon for your data set. So an example of the file is on the right side, right? Like you might see NG being written, for example, in English, but it actually maps to just a single sound, ñ, right? So on the left side, you want to represent orthography, so how things are written, and on the right side, it's phonemes, so how things are pronounced. And just another technical detail, please do not use tab between letters and phonemes. It actually relies on spaces, right? So like orthography, space, phoneme, new line, and so on. Thank you. Next slide. So as I already mentioned, that pronunciation rules are combined with a clean corpus to produce pronunciation lexicon. So what happens here is that we're producing like a vocabulary, like a dictionary, where every word is mapped to their pronunciations. Quite useful for the recognition, but let's imagine the following scenario. So for training, you might be using data set, maybe like outside of this challenge, you might be using a data set that already exists. And the data set language is not English, but it has some annotations in the corpus with like meta-linguistic information, something like people laughing, people talking, dog is barking, movie is playing. So it's important that everything like this needs to be cleaned from the corpus. Because first of all, the problem in this case is that, in this case, I think the language, if I'm not mistaken, is Aboy. It's a language spoken in Indonesia. And there is some meta-linguistic information like people talking also given in the corpus. And if we don't clean this from the corpus, it produces, or it also predicts new words and pronunciations that should not actually exist into Aboy language. So yes, long story short, just please make sure to clean the corpus. Next step. Right, so just again, the core idea of the last slide also was that we need to transcribe only the speech, so only something that you want to see as the output of the audio files. Because if there is something like ha 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 in the audio and it's transcribed as people laughing, it will actually model the acoustic representation. So yeah, so snippets like this should be removed. And another thing that I wanted to mention here is that only lexical forms should be included in the pronunciation lexicon. So if we have some non-lexical forms like 9 represented as a digit, just please make sure that you will spell this as a word. Next slide, please. And yes, just to conclude this section, I wanted to show you how Elpis looks like after you install it. There are several ways to install it. You can use it via Docker directly on your machine. You can install it using different cloud systems. But yeah, it shouldn't be too difficult. And then you will see a page open like you see here on the right side of the page. And yes, it should be quite intuitive and easy to use Elpis. It also implements advanced logging. So if something goes wrong, you're always able to access the logs and see what went wrong. And it has great documentation. So whenever you have some question, you can go check Elpis read the docs.io and it might be answered. And if no, we're always here to answer your questions. Please let me know if you have some right now. Thank you.
I really recommend that you use this time to ask Elena questions, because you will be creating machine learning ASR models with prizes up for grabs. So you have a short time. In the meantime, I'm going to hand over to Connie, but keep an eye out on the discussion forum.
There was one question from previous section. It was, what innovative ways can one use to crowdsource speech data for low resource language?
Yes, so I slightly answered part of this question during the slides, and let me answer the other part right now. So it's important to collect data in the target language from the internet. It can be done via Wikipedia dumps or via web crawls. So this will allow to get more data that can be then recorded for that language. And also the data can be elicited in different ways. You can either just ask different questions and record open-ended questions and so on. And also, another point about this language is, another point about this question is the Kinyarwanda language that we took a look as a part of the Mozilla Common Voice. So in that case, government incentivized speakers to donate their data, and actually a lot of speakers donated, and this allowed Kinyarwanda to leave the League of Lower Source Languages. So this is another way, just basically inviting more and more speakers to donate their data to make it open source. And actually something that is happening during this hackathon, where our target is to collect more and more data for lower source languages, is another innovative way to collect more speech data for such cases.
Thanks, Lena. Next question is ELPIS used for text recognition as well?
So ELPIS is more oriented for spoken language. So ELPIS is something that helps to collect spoken language in different ways, be it just recording, be it recording or elicitation using prompts or videos and so on. So I'm sure there are some other sources that that help to collect textual data more. And if I misunderstood your question, please let me know.
Thanks, Elena. I'm not seeing any other questions come in, so we can go ahead and move on to the next section. We're going to talk a bit about the hackathon challenges and resources. So the Africa NLP series is comprised of today's workshop and 2 challenges. There is the West Africa ASR Challenge, which runs from today till Sunday, the 13th. And this is a closed challenge, which is available to participants in West Africa. And for you to join this, there's a secret code. It's West Africa 135. The task for this West Africa challenge is to train a model on the dataset provided. At 5 p.m. today, after the workshop, the dataset will be released and the challenge will officially begin. And then following that challenge is the Intro to ASR Africa challenge. And this one is open to all, and it runs for a longer period of time, for 2 months, because you're collecting data. So the task is to collect speech data and train a model on that data. And when that challenge begins on February 14th, we'll also include more info about the challenge and the ELPIS tutorial on the data tab in Zindi. So if you haven't registered yet, we're going to stop for a couple seconds, a couple minutes for you to go sign up. If you got the email, the 2 registration links are there, or if you go to Zindi and look for these 2 challenge names, you can find them there as well. Okay, now I'm going to talk a little bit more about the 2 challenges that we have. So one thing to pay attention to for both challenges is if you look under the info section, we'll have more specific submission guidelines. For the West Africa challenge, you'll be submitting a model, and the winners will be based on the model's word error rate. For this challenge, you'll see a leaderboard with your submissions. And there's going to be 5 winners total for this, each receiving $200. And the 5 country regions are Nigeria, Ghana, Senegal, Ivory Coast, and other. And then for the Intro to ASR challenge, the submissions will include a data set, metadata, documentation, and a model. The winner will be based on the diversity of speakers and prompts, the size and uniqueness of the data set, quality of the documentation, and that a model is included with the data. And we won't be looking at the word error rate of your models because everyone's collecting different data, so it's not an equal comparison anyways. But we want to see that you're demonstrating that you train the model on the data. And with this, there's going to be 8 winners total. There is first, second, and third place. And then there's also $300 for each regional winner from Nigeria, South Africa, Ghana, Benin, and Ivory Coast. Whether you win the competition or not, one thing we really want to encourage is open sourcing your work. It is huge in fostering collaboration and would help advance the research and development of NLP in Africa. You can share your data and your models on GitHub, or you can consider publishing or submitting to conferences. And depending on your language, the work you put together might be the first or some of the first data sets or models for that language. So I think that's a huge accomplishment. And in terms of resources, so there's a discussion forum on both competition pages. We'll pay attention to those and answer questions. For the Intro to ASR challenge, we will have the ELPIS tutorial posted, and we'll have office hours every 2 weeks after the competition begins. In the discussion section, we'll post a link to the calendar session. And then all of the links referenced in today's workshop will be posted on Zindi as well, and a recording of this workshop. And any questions? We're actually, that is the end of today's workshop. So please let us know any questions you have for the challenges or any of the previous sections. We're happy to answer. Okay, there is, what amount of data do we need to build an acoustic model? We halfway answered like how much data is needed, but I don't know if for an acoustic model there's...
Yes. So we have some guidance regarding this question on the slides as well, but the rule of thumb that the training of a model needs to have at least 1 or 2 hours of spoken data.
Thanks, Lena. Next question, is it legal to use entries from a published dictionary of your language to create your ASR model?
So that's actually a very good and very wise question. Thank you for asking this one. So it's always possible to use some of the open resources such as Wikipedia because they're free to use for everybody. And when it comes to published dictionary to create an ASR model, so I will not have a fully prepared answer, but I would say that if you're using this this dictionary to crawl it, just check its licensing, because it might be allowing this for sure. But if you're just using it to inspire yourself to, for example, include certain words from this vocabulary, I honestly don't think it should be a problem.
Thanks. The next question, how do you use the model in an application that is not ELPIS?
So ELPIS is just one of the ways to train a model. And actually, after you already get the model, it shouldn't make a big difference about how you use it downstream, if it's ELPIS or not. So when you have a model, it's like a trained model that you have on your computer or on your cloud, and then you can link it to other downstream applications if this is something that you have in mind in the same ways as you would use ELPIS. Do I answer your question, sir?
Thanks. And next question is it okay if we have the parallel data to be of different languages?
The parallel data to be... So the importance of parallel data comes into play when we're developing translation systems, right? So that from translation, it's very important to have like parallel data where the same thing is being said in 1 or 2 languages. But parallel data is not necessary when it comes to training ASR models. So for ASR models, we just need recordings, and we need transcriptions of those recordings. And in this case, it's actually very important for them to be in the same language.
Thanks. And next question, Nigerian has 250 languages. Are we to pick any of the languages, or is there a specific language we are expected to work on? That's a great question.
This is in fact a great question, and you're encouraged to choose the language that you would like to work on. So it's very important for all languages ultimately to be represented, and for speakers of all languages to have access for this technology. So we're leaving this up to your judgments and up to it's also up to speakers of which languages you have access to. But yes, absolutely, please go ahead and choose the language that you would like. And Sandy also has something to speak about it.
Yeah, I just wanted to add there. I think it definitely it should be driven by your own interest and your research interests, etc. I think I would also add though that it's worth looking around at what's already out there. So for example, in Nigeria, I think like work has already been done on like, the major languages like Hausa, Yoruba, Igbo. So if you're interested in like really kind of innovating on a new project, maybe like looking into one of the kind of lower resource languages, the less resource languages would be a really fantastic way to, you'd really be building the first corpus, the first models for many of these languages.
Cool, thanks. Next question, do you process data before committing word error rate?
I'm sorry. Oh, okay. Now it's this. So word error rate is something that will appear as a result of model evaluation. And if you mean processing as in the case like cleaning the data and making sure that the corpus is sound and looking well, in this case, yes. So the training and the testing data are just like different sections of the same data set. It's just they need to be distinct, but they are prepared in the same way, and the data practices are the same for both of them. So yes, if I understand your question correctly, then yes, we need to pre-process data and prepare it also when we're doing the ASR model evaluation that results in us obtaining a word error rate. It's just a metric. So yeah, for who doesn't know what's word error rate, is just a metric that tells us how many words are we getting wrong on average given that model.
Yeah, maybe just to add that it's worth while you're in the process of training, maybe if you haven't processed all of your data, to evaluate the model, even before it's kind of completely finished training, and check whether the word error rate is like 100% or 0. In which case, there's maybe some problem with the setup or the initial conditions. So doing like during training evals is also sometimes a good idea.
Thanks. There's a clarification on the if it's okay if we have the parallel data on different languages. The clarification is, I meant if the audio is in a different language and the transcription is in English.
Yeah, that's not exactly the type of data that we usually use to train ASR models. So in the traditional way, we need the audio data in the same language as the transcriptions, because yeah, something what you were mentioning would also involve the translation.
Got it. Okay, next question. Is ELPIS totally GUI based?
So that's a great question. It can, yes, you can use ELPIS just using graphical user interface, but I do think that there are ways to run ELPIS from the command line if this is something that you desire.
Thanks. Any other questions? Nope. All right. Well, thank you all. Thank you so much to our speakers today. Thank you to the Zindi and DSN teams and Google teams for all the behind the scenes work putting this workshop together. And also thank you to all of the participants for tuning in today. And we're excited to have you join the challenges. And we'll be available on the discussion boards and hope to stay in touch. Thanks, everyone.